All right, in this video we're going to talk about what to do when both sine and cosine are even. So both sine and cosine are even. So in the past we've talked about what to do whenever we have, let's not fill this up. Let's say, can we say no fill? Come on now. I'm not sure that's going to work. Let's see. Okay, yeah, that's all right. All right, so we've got a box here. I'm not going to draw lines this time. All right, so say I had a sine that's even, a sine that's odd, and I have a cosine that's even, and a cosine that's odd, okay? So we know what to do if I have an odd cosine and an even sine. I use the odd cosine rule. Okay, what is the odd cosine rule? The odd cosine rule says that I strip off one of the cosines, I make that part of my du, and I write everything else in terms of sine. Okay? We also know what to do if it's an odd sine. An odd sine, what do? I strip off one of those sines, I write the rest of it in terms of cosine, and then I have the sine that I stripped off as my du. Okay? Now, if both are odd, so sine and cosine are both odd, so I'm down this column, sine odd, cosine odd, then it doesn't matter which of these two techniques I pick. I just pick, whichever one's my favorite one to strip off. I kind of like to strip off the cosines because I know u equals sine x gets me du cosine x dx, and I don't have to worry about that negative going on that the sine stripping off has. But, that's neither here nor there. You just pick your poison, which one of those two you want to use for that one. So the last scenario that we haven't talked about is what do we do when we can't strip anything off? I can't strip off to write it in terms of the other, and I get that differential that I need because they're both already even and ready to go. So we go to our reduction identity. That's what we're forced to go to. So if you'll recall, the reduction identities, sine squared x, 1 minus cosine 2x over 2. You just got to know these. You got to know them. And then 1 plus cosine 2x over 2. All right? So unless you know these identities, you're not going to be able to work this problem. So now we substitute, and I'm going to substitute this in here. So sine squared is 1 minus cosine 2x over 2. Sorry, I did not mean to put squared. That's 2x. And then cosine squared is 1 plus cosine 2x over 2 dx. Okay? And so what does this reduce to? Well, I multiply this out. I'm going to factor out a 1/4 because here and here, that's 4 in the denominator. Pull it out. And so I have 1 minus cosine, 1 plus cosine. So that's going to multiply to 1 minus cosine squared of what? 2x dx here. All right? Now, if I distribute this through, I get 1/4 dx minus 1/4 of cosine squared 2x dx. And so I know how to integrate this first part here. That's just 1/4 x. But I've got this scenario where I've got cosine squared of some stuff, right? Well, how do I handle cosine squared of some stuff? Well, cosine squared of some stuff is equal to 1 plus 2, cosine of 2 times the stuff over 2, okay? Now, what does the stuff happen to be here? The stuff happens to be 2x. So what is the cosine squared of 2x? This is equal to, and I'm using stuff here for a reason because it's a little bit different. I'm going to use a different color. Hopefully that'll help. So this is 1 plus cosine of 2 times the stuff. Well, what is the stuff? It's 2x, right? Over 2. Okay. So what does this reduce to? This is 1 plus cosine of 4x over 2. So since I had a 2x to start with in here, it turns into double. Remember your double here? And so that makes it the 4x there. So this is integral 1/4 dx minus 1/4 integral of 1 plus cosine of 4x over 2 dx here. Okay? Now, what do you notice here? You used a reduction identity here to get to this place right here. And you had to use another reduction identity because you had an even power of sine or cosine to get to here. So we're using 2 reduction identities in one problem. Okay, so make sure you know how to do this type of problem. All right, so integral of 1/4 is 1/4 x. And then I'm going to have what? Well, 1 over, dividing by 2 and multiplying by 1/4, that's going to get me this negative 1/8 going on here. Now I have 1 plus cosine to the 4th. I'm sorry, cosine of 4x. Okay. So I'm going to break this up again. So I have 1/4 x minus, and then integral 1/8 dx minus 1/8 cosine to the 4th. I'm sorry, cosine 4x dx here. So this one here, 1/4 x, and then minus 1/8 x. And here I have cosine, which is not any power, it's just cosine. So I can actually use a u substitution to fix my problem here. So u equals 4x, du is 4 dx. I don't have 4 dx, I got dx. So I'm going to divide both sides by 4. So dx is 1/4 du. Okay, so that's 1/4 du there. And then this here becomes cosine of u because I replaced 4x with u. So the 1/4 comes out front here. So this is going to be minus 1 over 32 integral cosine u du. And guess what? Cosine u integral, I think we can do that one. That is sine u. So this is equal to what? 1/4 x minus 1/8 x minus 1 over 32 sine u plus c. But we started the problem in terms of x. I want to finish in terms of x. U equals 4. So I'm going to combine this here. That's going to be 1/8 x. And then minus 1 over 32 sine to the, and then 4x inside the argument plus c here. Okay. So this is a example. So this is an example where we have sine and cosine both even, and then you have to use the reduction identities, and we use the reduction identity twice here, right? And I wanted to show you this problem because students sometimes have a hard time with seeing what to do if this wasn't just a plain Jane X in here. Okay, if it's a plain Jane X, it's pretty easy, but whenever it's, you know, maybe a 2x in here, you know, sometimes they have a little trouble knowing what to do in there. All right, a lot of times students will write 2x there, and so I wanted to show you this so that you didn't make that mistake that others tend to make.